So I'm probably the one that knows the least about hemp in this whole room. So I'm a machinery guy, engineer by training, and done a lot of work in precision agriculture and GPS and all this kind of stuff. And I provide the extension support for machinery in the state. And that's kind of what precipitated folks contacting me and saying, hey, we've got this issue with hemp and harvesting hemp, can you help us out? And so I'm always interested in the challenge, and so it's kind of fun. So what I'm going to do is I'm going to spend most of the time looking at this hemp flower harvester that we developed, but I want to say a couple things about just the mechanization in general and harvesting, not only for the pharmaceuticals, but also for the grain and fiber and everything else, and how, you know, there's a lot of work to be done here looking at this crop and what is the best way to produce it in terms of how we can engage it with the machinery. And so hopefully there'll be some comments that'll stimulate a little bit of thinking here and some good stories. So I'll start with the story of where this started back in about April. County agent got together, and actually David Williams was with me in that meeting with a farmer who had this issue of, I need to harvest the flower tops of a hemp product. And this was a company that was contracting him to grow this product. He was kind of sketchy about it and sort of secretive, but he said, I need the top foot off of this plant to be able to use this. That's what this company wants for pharmaceutical production. Well, his perception when this project started, the initial contract, was he was going to grow about 3 acres. So he's thinking a bunch of neighbor kids, scissors, and grocery bags, and we can go and harvest it. And then when it turned out it's going to be 30 acres, he said that's too many kids, so we need some type of a mechanical solution to help us out. And so he originally talked to me about ideas. We bounced ideas back and forth. What are we going to do for this and everything? And I gave him some of my ideas and see where we can go with it. And so that's kind of ended it for a while. And then about June, the sponsoring company came to us and said, yeah, we actually have 4 locations. We really need some help. Do you have some ideas? And so we worked with them a little bit more, some more ideas and everything back and forth. And we said, yeah, we could do it. It's going to take this much. And yeah, okay, let me think about that. So then they finally came to us in July and said, yeah, we need this thing, go ahead and do it. And then I asked the question, when do you need it? Yeah, you know when that's coming. Yesterday as we need it. So they said, okay, September 1, you get deliver something by September 1, we're okay. Folks, that's from middle of July to September 1, that's 6 weeks. And so we took it on, turned it around, and I'll bring out kudos to our design and fabrication folks in the department. They are excellent people, and we pulled something together. But I want to get you in the head of an engineer for a little bit, and I don't suspect there's very many engineers in here, but when we approach a problem, and I think this will help us think about this whole hemp thing, when we approach a problem, we got to look at what are the design constraints. So what are the things that I need to think about in terms of what I'm trying to accomplish? And if we start thinking about those design constraints and putting that in perspective of this whole crop and the cropping system and how we plant it and what our seeding density is, what our genetics look like, now we can start to think about how the whole system works together. And so when we sat down with the group, we said, okay, what do we need to do? We need to cut and capture the top of the plants. Okay, I can deal with that. I can understand that. What's the nature of the plant? How high is it? Well, it could be this high, it could be that high. So therein becomes the challenge. So we were looking at cut heights. We want the top foot of the plant. You know, they're suspecting plants can be anywhere from about knee high to about 10 to 12 feet high. So they're saying cut heights of 1 foot to 10 foot. You know, if we could be 1 to 4 foot, or 1 to 3 foot, something like that, we could really use some traditional, conventional forage equipment. That wouldn't be hard to do. And we could, there's a lot of that out there. It's off the shelf. We could buy it, put it in the field, and away we go. We start getting 5, 6, 8 feet, and all we want is the top part of that plant. Now we need something unique. How do we lift the equipment up there to be able to capture that? And so that was what became the unique challenge for us, and it was kind of fun. How are we going to do this? What are we going to put it together? Some of the other things I talked about, hey, we want this to be portable. We've got multiple sites from central to western Kentucky, so we don't want to have a big production and a big heavy machine that we got to drag around. We want something light enough that we can move, okay? So there's another design constraint that we can think about. How do we share this stuff between different producers, different operations, and so forth? We wanted to cover 20 acres per day. Okay, well, I can think about that as an engineer. How wide's my machine? How fast does it have to go? But as I'm going through the field, how much material am I going to be collecting? So what am I dealing with? So I said, what do we know about the plant? They said, well, not much. And so therein becomes the challenge. It also is kind of fun, too, to kind of deal with something that we don't know about. And so we went to literature, borrowed a lot of different stuff from different plants, trying to figure out what does this stuff look like. We know it's sticky, you know, and that's about all we know, but, you know, how sticky, what happens if we put it together and pack it down and all that kind of stuff. So we don't know. And then the other thing I asked him is, okay, how are you going to get this? You're asking me to cut it and get it to the edge of the field. What are you going to do with it from there? Well, we're not sure how we're going to get it to the processing plant. I said, this is green material. You put green material in a pile, guess what happens, all right? The center of that material, the temperature changes, the microbes come alive, and a lot of things happen in there. So, how are we going to handle this thing from the field to the edge of the property? So there's a lot of really interesting conversations that we had, but again, I'm trying to get you in my head as an engineer to think, okay, I got a problem. How do I define these things to be able to solve this problem? These are some of the questions that we all have to work together to answer to be able to come to a solution that's going to work. Okay, so it's not just a machine to solve a problem, it's a machine working with a system to be able to come to a solution that's workable for all of us. All right, so what do we come up with? This is the machine that we built, and we had a lot of names for it. Most of them I won't share with you here, but it's a very simple machine. Actually we stole a sickle bar and a reel cutting mechanism off of a combine head, so we used what mechanisms we did have, and that'll cut the plant, the reel that'll feed the material in. The unique thing that we did was build a conveyor system that would actually move the material to the side of the machine and discharge it. So we can cut the material, move it to the side of the tractor, and capture it into something else. And I'll talk about how we capture it in a minute. So we had that side to discharge. The portability, we made this thing a loader mount. So this thing will clip onto the front end of a tractor. These mounting systems here are a standardized mounting system. So the beauty of it is any tractor with the proper adapter, we can just clip into the machine, pick it up, and go. So there's no fancy mechanism, no bolts and brackets and all that kind of stuff. It's a pretty simple way to connect it and go with it. The other thing we did to make it as portable as possible is we use an electric drive, which is kind of unusual. So most equipment like this in agriculture, we would use the hydraulic power from the tractor, the oil and the fluid and everything in there. But for a machine this size with this capability, that's going to take some special capabilities of the tractor, which is going to limit the tractor that we can use. So you would have to have a fairly specialized tractor. So now we're dragging tractors with us, and we don't want to do that. So we went with electric drive, and then the electric power we provided from a generator that's mounted on the back of the tractor. So standard hitch back there, power takeoff and everything. We can hook that onto any tractor, and essentially we plug the extension cord from the back of the tractor into the front, and the way it works. And so it kind of gives us that portability. And selfishly, from my standpoint, we got to learn a lot about electric drive because we're seeing more and more of that in agriculture, a lot of efficiency and controllability. We're seeing a lot of electrics coming in. And so you can ask my students in the machinery design class this fall, they had to redesign a lot of this stuff all semester. They got sick of hemp, let me tell you that. So, but I even brought some into class and said, all right, how do I harvest this stuff? So put it on the table, and how do you get the seeds out of that thing? So that was kind of a fun exercise one day to have the students. They all walked out of the class smelling like whatever. But okay, so second question then, all right, that's the cutter, how we get it off the field to get it to the side of the machine, how do we capture it? Frankly, we didn't spend a whole lot of time on designing this receptacle system, if you will, because I'm not sure this is a long-term solution. But what we decided on with our sponsor was to use these cubic sacks. So it's a large sack. It has loops on it that you can handle them with a forklift. So again, simple, any kind of a machine with forks on it, we can pick them up and move them around. So we made this rack with a conveyor that hooks on the side of a truck. It has kind of a big hopper here that we can throw the material into it, and this conveyor will move the material up into that sack. So we run the truck beside the tractor, catch the material as we go through. Long term, we'll probably look at a lot of different solutions and ways to capture this material, put it in some type of a bulk handling system, but that's what we did for now. So you can see the truck running beside the tractor there as we go through the field. If the computer has a capability, and it does, we'll be able to see a video of this thing running in the field. So this was some harvest that we did near Owensboro, Kentucky. This is beautiful hemp, so sarcasm. Obviously at about 1.5 feet or 2 feet tall, we could have used about any kind of hay equipment to capture this. So we did test the lower limits of the cutting ability of the machine. But it is taking the tops off there. You can kind of see the generator on the back of the tractor that's providing electric power. Tractor's moving along there with the truck beside it. And so we'll see a front view here in a second where you actually be able to see the material being cut. You can see the conveyor there that's throwing the material up into that catch conveyor and putting it into the sack then for for recovery, and generally it worked pretty good. We had really good material flow. It did what we expected it to do. Again, this is 6 weeks. Keep that in mind. This is 6 weeks, even with the paint and the stickers too, so we're kind of proud of that. A little bit of material flow issues in the corners. You know, there's some things that when you do something that quick, you miss little details here and there. And so there's a number of things that we would like to change with it. You can kind of see some material building up there a little bit, but it didn't really hamper the function of the thing. It still functioned very well. Material being put in the conveyor over here. We'll see the conveyor putting the material into the sacks here in just a second. We did have to have somebody riding along. The material that we were harvesting was drier than we would typically want it. And so the very dry, light material just wasn't heavy enough to actually get down into the sack. So we actually had to have somebody there kind of feeding the sack. I think if we had a little wetter material earlier in the season, it would fill the sacks a little bit better. And we would have been okay. But that's how it worked. We got it off of there. Again, I'll shout out to these guys over in the shop that put it together, burly looking group there. This guy on the right is Will Adams. He's the head of that group and fantastic designer. And they did a great job putting that thing together. So, did it work? Yeah, it did work. So we managed to get through 2.5 acres before we found the critical mechanical flaw in the system. But for the first day out, that's not too bad to get that much before it actually lets the smoke out of it. And again, the material flow did pretty well. We had a couple minor issues, and especially with the electrical system, we learned a lot from that, and we have a few components that we need to redesign. But basically, with a couple tweaks and everything, that same machine can go back out in the field next year and get it done. But again, we have a lot of design modifications that we think about. And again, we're thinking in a larger system here now. Because where do we want to go with this? Yeah, we have these little machine improvements. We need to think a lot about how we're going to package and handle this. I'm not sure that these sacks are the long-term solution that we really want to look at. But we're eliminating this dual-use potential for this crop because the way this thing is set up, and again, we had 6 weeks to get something to get the plant tops, and so that's what we did. But that machine on the front of the tractor's running over the stems, and we're smashing a lot of them down. Do we have a way that we can recover the plant stems for the fiber production? Okay, and so we're thinking about a lot of different ways to do it, but one of our ideas is some type of a trail-type implement. Instead of being in front of the tractor, it's off to the side and behind the tractor. We can clip the top of the plants off, save them, and then either at that point, you know, gather the fiber material, cut it, lay it somewhere, or package it separately, or however we want to do it, whatever the process is going to look like. So I think there's a lot of potential here to be able to do this, to be able to recover both of those in one unit. We're not there. We'd love to be able to do that, and so I think there's a lot of potential to do that. So there's, you know, we talked a little bit about the cannabinoids. We talked a little bit about the fiber. What about grain harvest? So I actually got involved with another farmer this fall who had some grain, and that's what he was going to produce. Okay, very different system. And, you know, and David Williams mentioned a little bit about this, how you're going to harvest this stuff when I've got a plant. That tape measures up 9 feet, so that's a 10 to 12 foot crop that we have to get into a combine, okay? Seeding rates on this were significantly lower than what he was expecting. So this crop was actually planted like corn. So on 30-inch rows with a wide plant spacing. So we had a very bushy crop. Is that the best way to go? I don't know. Maybe we compare yields, and I don't have his numbers, his final numbers to be able to say that. But there's, again, a lot of people experiment with different ways to do this. And so the farmer contacted me and said, hey, how do we set up the combine to get this stuff through? We've never done this. And so I figured, yeah, a lot of people in Canada and Europe, other places have run this stuff through there, but they're not running big, tall plants through there. So I contacted some of my colleagues in industry, and I actually did a sabbatical in industry for 6 months. So I knew some of these guys, and I asked them some specific questions. A couple emails came back and forth, and the last one came from them, said, good luck. And that's where we were. So they didn't know. They don't have this information. Again, this is something new. We don't know how to get this stuff through. So we said, all right, good luck. How are we going to do it? Can we get it to feed through the combine? What's the efficiency going to be, and so forth? So I went down. He put his combine down in the field and went through it, and by gum, it took it through, okay? Now, we've got some issues there, but it did take it through. The combine chews up the plant material, grinds it up, puts it out the back. Interesting bed of fuzzy-looking material. It's really cool-looking stuff when you grind up that stalk and it comes out there. It kind of looks, I don't know what it looks like. It was really different. But the photo doesn't do it justice. But maybe there's some opportunity to recover stuff from out of the combine. So I think there's a lot of potential there for utilizing that material as it comes out of the back of the combine. But here's the issue. You look at the size of that crop with that combine going through there, how do I get it in that head? So that reel in the front of that combine is designed for wheat and other grains like that, where it goes over top of the grain, pulls it into the machine. When that plant's up above it, that reel can't get over top of it, so what's it do? It just keeps beating on the plant till it finally breaks it enough to grab a hold of it and pull it through. What happens when you beat the plant? All that grain gets shaken off on the ground out in front of the combine. So we actually tried to figure out how much that was. That's a little baking pan that we threw out in the field there to try to catch the stuff that falls before the combine goes over it. And that's kind of what it looked like. That's how much grain fell in that one pan. We ran the numbers on it. We're looking at about a 30 to 40% loss right out of the front of the combine. So, okay. So how do we address this? Do we go back to planting date and stuff like that Dr. Williams talked about? Or do we look at the machine and say, hey, the plant's there, the seed's there. Is there another way that I can get that material into that combine? So I think there's opportunities in a lot of different ways to solve these problems, both through the genetics and so forth. So issues, getting it into the combine, that was a big issue in all those field losses. The other issue is that it's a continuously maturing plant, so it doesn't have one maturity date. So if you look at the ground, and again with the screen resolution is a little different to see what's going on, these little green plants there, this is before we harvested, that's volunteer hemp. So the early seeds were dropping, they were going up, and actually when you really zoom in on this picture, the ground is almost covered with seeds. Can we recover those seeds? Do we go at this from genetics, where we look at a single maturity date? Or maybe we look at a different harvesting system where we do multiple harvests. Let's go out and capture some of those grains and every week or two do that. Is there ways that we can go about doing something like that? So different systems, different mechanical opportunities here that I think we have. And there is some unique plant properties. So it's a fiber plant. And so when it starts to wrap on a piece of equipment, it keeps on wrapping on that piece of equipment. You don't just go out and grab a hold of it and pull it off. You cut it and you dig it and tear it off. The other thing that you find with hemp is that those fibers get ground up and you get really small microfibers, and they like to get into bearings, and they're really hard on bearings. So I asked the farmer, I said, is this a combine you're going to trade off next year? And he said, nope, it's better. It's a leased one. So it's going. So that's something to think about. What are the bearings? What's the long-term impact of this material that we're running through this machines? How do we deal with it? Okay. So there's lots of questions. So I think I call that job security. I think there's lots of opportunities for mechanization to work in this. We're excited about it. We'd like to keep working and doing some things in this area. And we need partnerships. And again, this is a whole system. That's why I spent that time getting you in my head in terms of these design constraints. We need to be thinking as a system, and how does the machine and the genetics and the planting and the cultural practices, how does that all impact how we get the most economic value out of this crop as we move this crop forward? And so I hope that's a message that you hear, see some pictures of a cool machine that worked pretty good. That sticker was the best 40 bucks I ever spent, I think. It gets lots of photos, but we'll go from there. So if we've got a few minutes, David,
yes, absolutely.
I can answer some questions as much as I can. Yep.
How in the world have the Europeans been able to harvest hemp all these years? We're just now looking at
Yeah, that's a,
That's a question. You know, we know other people are doing it. And when we went to try to find information, nobody's publishing information about it. And so, and I don't know what the reason for that is, whether it's a secretive group or whether nobody has just bothered to publish it, but it's hard to find published information about what's going on. And this farmer that I worked with who was harvesting the grain, he tried to contact some other people in Canada and other places like that, and he said they just are not willing to talk. So, and I don't know why that is. I don't have a good answer. You know, we're getting into the social sciences there, and I don't know. But yeah, there's not scientific information, certainly none out of the United States, because somebody would ask how you got that data, and that would be an interesting conversation as well. So, yes, sir.
Did you explore any kind of a sickle, elevated sickle opportunity as opposed to a paddle wheel?
Well, there was a sickle underneath it. So the paddle is what just pulled the material onto the sickle and make sure it fed in and didn't fall off the front. But no, absolutely, it was a sickle on the bottom there. That one worked very well for what we were doing, and I talked to some colleagues in Europe that have done a little bit on that, and they said those sickles with that guard sticking out in front, those of you familiar with that, he said they're going to have a tendency to catch those stalks, and you get one hung on there, and then it's going to plug the whole thing. So he said that's going to be a challenge. He said long term, you probably want to look at some of these opposing sickles where they don't have a guard sticking out in front. So I think there's some subtle things like that that we need to be thinking about to make this thing long term productive, a long term solution for it. In 6 weeks, that's what you get. So, yes, sir.
Do you know the rough moisture level that you were harvesting at?
In terms of the,
Plant moisture?
yeah, we did. David's in the back. I don't know whether you guys checked that or not. I never did check it, so I don't know. It was drier than what we want it to be, so it had gone to the point where it wasn't really green and as sticky as what it normally would be, but I don't have a good feel for that. So we were later than optimum, and that's one of the reasons we were focusing on getting the machine out, and we just didn't really worry about getting all that other kind of data because its relevance would be somewhat suspect, I would think. Yep. Yes, sir.
Is there any thought of taking the entire plant from the bottom, getting it all, and then shaking out all the seeds, and then having the material to work with later as well?
Well,
Instead of like trying to cut it and leave things, just take the whole thing and then use it and work with it.
Well, we've had a lot of those conversations. I don't remember whether that was a specific thing or not. I mean, we've tried to look at a lot of things, and that's where we need these conversations to come up with unique solutions because this is a completely different product. So, I talked about that material coming out of the back of the combine. Can we use that the way it is? Or like you say, do we need to come up with a completely different threshing mechanism where we take the plant, we pull the seeds off, we preserve the stalk,
When you're hitting it and if you're shaking off all those things, I'm just wondering, scooping up everything.
yeah.
Because at the end of the day, you want to use everything.
Right. And we've talked about that. So some different heads that would look more like a corn harvesting head where you have fingers that would go down between the wide rows that would capture the plant and engage it rather than just like we're doing now, just trying to grab a hold of it like a cat and pulling it in and just beating the heck out of it. Yeah, that's not the right solution. So that was what we had, what we tried to get it in, and that's where it is. Now when we're just harvesting the tops, that works very well because that's a very gentle, the way that one was a very gentle solution, and we could get over top of the crop and pull it in. But it's,
Grain, it's different.
yeah, if I can't get over top of the crop, depending on how tall it is. Now, if I'm growing it different ways, with a more dense seed spacing and all my seeds are on the top of the plant, then I don't need that whole plant. I don't need the crop down there. And then we see solutions out of Europe where they're actually taking the top of it off for the seed, going into the combine, taking that part through the combine to take the seed off of it, and they've got a second head underneath on the front of the combine that'll cut the plant and leave the plant underneath. And so they're doing that in two separates. But again, that's two heads on the front of a $500,000 combine, so we're talking about a really high dollar solution there. So do we have the acreage to support something like that? Maybe eventually we do. So, but that's the kind of vision that we need to look at for long-term solutions. Absolutely.